Welcome to Ask and Learn.
Okay, so for the first part, we want to show that 2n is big O 3n, right? So that gives us an f of x being equal to 2 to the x. And our g of x then is going to be 3 to the x. So when I'm referencing f of x and g of x, this is sort of what exactly is big O? Well, f of x is big O of g of x if the absolute value of f of x is less than or equal to some constant times the absolute value of g of x. Right, so that's what we are aiming to prove. So when x is greater than 1, then we have the property that 3x is going to be greater than 2 to the x. Okay, so for convenience, we're just going to let k equal 1. Thus, we're sticking with this letting x be greater than 1. And you could certainly choose other values at k, and they would suffice. Okay, so that gives us that the absolute value of 2 to the x then must be less than or equal to the absolute value of 3 to the x. Okay, so if we take c to be equal to 1 or larger than 1, then with k equal to 1, that is having x being larger than 1, and c being equal to 1, the constant that could go in front of this g function, then we have that it is, in fact, big O. So that one kind of takes care of itself. But now I want to show that when f of x is equal to 3 to the x and g of x is equal to 2 of x, then it's not big O, right? So we're switching the functions here and showing that it is no longer big O, okay? So we'll do this as a proof of contradiction, right? So let's assume that f of x being equal to 3 to the power of x is big O our g function, right? And then if we obtain a contradiction, we'll know it's not true. So if this is the case, then it must be true, right, that 3 to the power of x is less than or equal to some constant times the absolute value of 2 to the power of x. For some k value when x is larger than k. So we don't know what these constants are. But we're just going to say, let's assume k is greater than 1. Right, so it's a very low boundary, so it's a safe assumption. And we also want to assume that c is greater than or equal to 0, which is also a safe assumption since absolute value is always non-negative. Then this gives us that 3 to the power of x absolute value is just going to be equal to 3 to the power of x here, right? But this must be less than or equal to c times the absolute value of 2 to the x, which is just going to be equal to c times 2 to the power of x. Okay, that's because of the assumptions made here on k and c. And so we can rearrange this inequality, right, where we sort of have gotten rid of our absolute values. And so we can divide both sides by 2 to the power of x. That gives us that c must be greater than or equal to 3 to the power of x divided by 2 to the power of x. Okay, well, that's the same as saying c is greater than or equal to 3 halves to the power of x. And if you solve this for x, you get that x must be less than or equal to log of 3 halves c. Okay, but in this case, x is greater than k. Right? And there also exists x values such that x would be larger than this log of 3 halves of c. Okay, so this gives us a contradiction. And therefore, it is not